is equal to 2 seconds. That is the time instant. That means 0 to 2 seconds, 0 to 3 seconds, like this. So Sn means displacement is equal to u plus a by 2, 2n minus 1. Right? U is the initial velocity, a is the acceleration, n is the nth second. So this question also we had seen. One question, this type of question I think had come in your assessment also, class assessment. Quickly note down this question. I'll discuss this. This formula only will be applied. The same formula. S is equal to u plus a by 2, 2n minus 1. This formula only. Quickly note it down. So u and a, these will be two variables for you. So it is like linear equations with two variables.
Done.
C class. Here when we are saying a body covers 12 meters in second and 20 meters in fourth second. So you have to mainly form two equations. Fine. Now in these two equations, one variable will be initial velocity and second variable will be acceleration. So if I say S2 means displacement covered in the second, that is going to be 2, right? And no, that is going to be 12 meters, right? Second. And what is n value? N is 2. Initial velocity, we do not know. Acceleration, we do not know, right? Then it is telling you displacement covered in fourth second. This is given as 20 meters. And n's value is given to you as 4. And acceleration and initial velocity, these are unknown. So if we go by this equation, Sn is equal to u by u, Sn is equal to u plus a by 2 to n minus 1. So in 1, you will put this, right, with u and a as variables. In second equation, you will put this again as u and a as variables. So see, this is going to become 12 plus 12 is equal to u plus a by 2, this is still unknown. N was 2. Yes, n is 2. So that becomes 2 into 2 minus 1. This is 2 into 2 minus 1. This is one equation. So let me write it properly. This becomes 12 is equal to u plus a by 2. 4 minus 1, which is 3. So 3a by 2. Right? This is your first equation. Second equation will be, this is 20 is equal to u plus a by 2. This was n2 was given as 4. So 2 into 4 minus 1. That becomes 20 is equal to u plus a by 2. 8 minus 1, which is 7. Right. So one thing which you can do is multiply just to solve this. See, these are two equations which you have and you just need to solve this. What you can do, you can multiply this entire term by 2. So what will happen? This 2 will at least get eliminated. Fine, then you will have two equations which you can solve. Now these two equations, at least you know how to solve. Tell me what is the value of u and a coming. Did anyone solve? No, till now nobody has answered this question. Two equations are there with you.
Ma'am, we can just subtract one.
Yes, Martin, you're doing?
We can subtract one.
Yes, you'll subtract. Yes, you will subtract these equations, then you will get. See, if you multiply these with 2, you will get 24 is equal to 2u plus 3a. This equation you can use. And this will become 40 is equal to 2u plus 7a. Subtract these two equations. See, if we subtract these two equations, 7a plus 2u is equal to 40. And what was the other equation? 3a, right? 3a plus, it was 2u. This was also 2u is equal to 24, right? I hope this was the equation. 24 is equal to 2u plus 3, right? So you can subtract these, signs will change. This will get cancelled in any ways. This becomes 4. So 4a is equal to, this is 16. So acceleration will come out to be 4 meter per second square, right? So if we know the acceleration, you can put it in the value of any of the equations. You will get the value of u. Fine. What u will come? Just put as the value of a as 4. You'll get your answer. Tell me what is the value of u coming, initial velocity. Okay, note down the solution first. This initial part you have not written down. Quickly note it down. Question you people have written, or do you need more time? Okay, note it then.
Ma'am, what was the acceleration of this?
Completed till here?
No, ma'am.
No, Sarah, no need to use v is equal to u plus 80 for you. See, you can calculate, put it in any equations out of these two. Once you know, like if I put it in this a, 40 is equal to 2u plus 7 into 4. So I can get the value of u now, right? So two equations and two variables.
What is in the brackets? Like 2 into what is that?
Where this
Yeah.
2 into 4, we have no 2 n minus 1, n is 4.
Ma'am, so U is 4.
How much are you getting, Sarah? You?
4.
U is also coming 4. Others, anyone else? Let me just wait for 1 or 2 minutes. I'll tell you the answer. You just need to solve this equation. So nobody else has given the answer
And
for
that's 10 equal to 2u plus 7 into 4, right?
where? This?
Yeah.
This is not 10. See, this was our equation. 40 is equal to
Okay.
2u plus 7u. So that is 40.
No, ma'am, I am getting answer as -6.
Ma'am, I got 6.
Minus 6 you're getting, Sarah. Plus 6
I got
Yes.
6.
you're getting, no? 6. Abdullah, who is getting the answer as 6? Someone answered no right now. Martin,
Yes, sir. No, yes, ma'am.
you had answered no 6 right now.
Yeah, 6.
Okay. See, it should be 6. 40 is equal to 2u plus 28. This is going to be 28. So 40 minus 28, this is will be 12. So 12 by 2, 6. Yes, this should be 6 meter per second. Just check the calculation, Sarah. If you're getting the earlier you were getting completely wrong. You were getting 4, right? Now
Yeah.
just check. It should be plus 6. Written others, all of you. I just want to discuss one question from this part, which comes a lot in your school exams. If anyone is writing, let me know. Otherwise, I'll move forward then. Okay, this is one question. This says that A body starts from rest and accelerates at rate. See, now this is different from your nth equations. All those questions, no, from nth equations, this we have studied completely. And SN equations, two questions also we have seen. That is, this is from the normal equations which you have from uniformly accelerated motions. Now see, this says that a body starts from rest and accelerates at rate alpha to a maximum velocity. See, if you just directly read it, it will become very confusing for you. So what I tell you, keep on drawing it, keep on writing whatever data you have. And one more thing, class, you have this exam no on Friday. So physics portion will be this lesson only, motion in a straight line. All right. So you will not be having separate lesson or separate test for differentiation, integration and all. That will be included the way the questions are asked, because in your exam also you will not be, in your main exam, school exam also, you will not be having separate questions on differentiation, integration, mathematical questions. So whatever portions of differentiation, integrations are involved, that will be within the questions only itself from this lesson. So motion in a straight line will come, whatever we'll complete till Thursday. One more class, no, we have, this is Tuesday, Thursday. So motion under gravity, I'll tell you today, that is not very difficult, but relative velocity, I'll try to complete it on Thursday so that you can appear for your exam on Friday. So these equations only will come. Differentiation part, do it well, where the questions, no, we have studied from 0 to here, and instantaneous velocity, average velocity, those questions, questions on displacement, distance, these are important for you. Not only for this exam, for your school exams as well. Questions based on displacement and distance, a circle path is given. These questions we have discussed, and we have discussed all the instantaneous and average calculations portions, where you have to find out the average one, where you have to find out the instantaneous. So appear for the test won't be very difficult. Test would be easy. You will be able to do even if you practice the class notes well. Whatever questions we have done in the class notes, do it twice, thrice by Friday. Fine. Now see, these types of questions can also come. These types of questions are your basics for your motion in a straight line, where a body starts from rest and this happens, that happens, which we have discussed earlier. This is one question that keeps on repeating itself. So that's why I wanted to discuss this with you. So the body starts from rest. This is u is equal to 0. Then it accelerates with acceleration alpha and achieves its maximum velocity v. Let us assume the maximum velocity is v. Then it retards. Can anyone tell me what was retardation? In one question we had discussed what is meant by retardation. Anyone of you? Retardation. Negative acceleration. Very good, Abhita. Negative acceleration means when your velocity is decreasing. When the velocity is decreasing, it can decrease up to 0. Fine. Means velocity has achieved its maximum value. This is what the question is saying. The velocity has achieved its maximum value. So then it keeps on decreasing. It keeps on decreasing, and finally it can become 0. So when the velocity decreases, then we call the acceleration as deceleration or retardation, and you have a negative sign in the question. So that's why we'll also put, when we are discussing this, let's say this is C point, acceleration, I'll put it as minus beta. It is given no plus beta. I'll put it as minus beta because negative acceleration it would be to come to rest. So finally this V final, this is 0. If total times elapse, the entire times that has been elapsed between these, this is T. The entire time that has been elapsed, this is T, total time. Then it is saying find this. This is your unknown quantity which you have to find. Find this. This is unknown. So what we do, whenever you have such types of questions where this entire story path is mentioned to you, so do one thing, time to total time is given, no, ST. Do one thing, go story wise. If A to B segment was given to you, initially, go story wise. If A to B is mentioned to you, we'll go from A to B first. We'll calculate questions from A to B. Yes. So we'll go from A to B. What all things we have? Initial velocity is 0, right? Acceleration 1, first acceleration, this is alpha. Maximum velocity. Maximum velocity is capital V, which is unknown, which we have to find out. Right? These things are only mentioned, nothing else is mentioned. Let's assume the time that has elapsed in this duration is T1. Total times elapsed is T, so you cannot use small t. You cannot use small t because small t is the total times that has been elapsed. We are currently talking about time that has been elapsed from A to B. Fine. So if we are talking from A to B, V is equal to U plus AT we can use. What is V? Still we do not know. We have to find this V. U is 0, so this becomes 0 plus acceleration is alpha. And see, we cannot use this t because this is the total times that has been elapsed. We are just considering this segment from A to B. This segment we are considering. So this becomes T1. So what is the value of T1? T1 is V by alpha. Fine, we have solved it from A to B. Coming to B to C. Now C class, if I again apply this equation, V is equal to U plus AT, V is equal to U plus T, AT, what all things are mentioned to us? Initial velocity, final velocity. Just look at this segment BC. This portion BC. This is our starting velocity. This is our ending velocity. This is the acceleration. All right. Yes, Sarah, can you tell me what will be the initial velocity for just BC, not the entire? Entire was this. In A to B, we had U as 0. What will be the value of U from this B to C? Sarah.
You will be unknown.
How much?
I don't know.
What is the initial velocity in B to C? What you can notice in this figure is mentioned in front of you. V. V, capital V. Because see, this was the final velocity for A to B segment. But when we are considering B to C segment, from this, the initial velocity is actually this. This is the starting velocity, no? So our initial velocity, see, if anyone is having any doubt while putting this, because now we just have to substitute everything, you will get your answer quickly. So this is the main step. This is right now your initial velocity. This is the final. When we are talking about initial velocity, your initial velocity is capital V, right? Now, Siddiqa, among this segment, what is the final velocity? B to C, final velocity. I have written it also on the screen. Siddiqa. Yes, Siddiqa, you are present or not? Yes or no? Afnan, right? Siddiqa, so if you're present, look at the screen from B to C. Which is the end final velocity which you can observe? Or it is also written in the question. The body comes to rest. Finally, the body comes to rest. This is written also, no? Here, at a constant acceleration to come to rest. 0, right? This would be 0. Final velocity is this 0. Please understand this class how to put in the values, because these calculations will always be easy for you. Whenever you will see the questions, the main problem will be substituting. And science, today we will do motion under gravity. There the same things are repeated. No new formula, only these formula will get repeated. It's just that you have to comply by the sign conventions. So final velocity is this time 0 and initial velocity is V. Whereas initial velocity was 0 and final velocity was V. This you have to keep in mind. Acceleration is given as minus beta. Now see, time. Time again, time, let's say this is T2. Let's say this time is T2. So what is the value of, because see, again, time for this segment is not given. Let us say this time is T2. So what is the equation? V is equal to V minus beta T2. V is equal to beta T2. What is the value of second time? V by beta. Now you have value of T1 from here. you have value of T2 from here. What is T1 plus T2? What is T1 plus T2? Yes, class. What is T1 plus T2? T. Very good, Abdullah. Total time that has been elapsed from, if you calculate this segment T1, right, and this segment T2, if you add it, you will get the total time that has been elapsed. So you have T1 plus T2 is equal to T. So that was V by, you have V by alpha plus V by beta is equal to T. Take V common, you have 1 by alpha plus 1 by beta is equal to T. Take their LCM. Alpha plus beta divided by alpha beta is equal to T. Now, what was our question? You had to find out the maximum velocity. V was unknown, right? What would be V? Alpha beta T divided by alpha plus beta. This was our question. We had to find this V, right? Note it down. Wherever you are having doubt, text me. I'll repeat it. Quickly note it down. Now you just have relative velocity left and motion
Ma'am,
under
can you
gravity
repeat?
we'll do today. Yes.
Ma'am, can you repeat from T1 plus T2?
See, T1 was the time that we had assumed, no, between A to B, T1, which we had found using the equation V is equal to U plus AT, from which V by A was obtained. Secondly, we had seen that from B to C, from the segment B to C, time elapsed we had taken as T2. But can we use T1 and T2 in our answer? We cannot use. Reason: it's not mentioned in the question. You can never assume variables which you have chosen. Right? T1 was never mentioned. It was I had chosen T1. Alpha was given, so my answer can contain alpha. My answer can contain beta. My answer can contain T, but not T1, but not T2. No other variable which is not given. Not X, not Y, not Z. No other variable which is not mentioned in the question. So I had to eliminate T1 and T2. So the best method is add T1 and T2. T1 and T2 were the time from A to B to B to C. So if I take them total, if I combine from A to B, completely A to C, that would give me total time T. So T1 plus T2, I had taken it as T. And then I kept the values of V by alpha plus V by beta, from which the equations which I had concluded. Clear, Sarah?
Yes, ma'am.
Okay, one more thing I wanted to ask you all. Is there any student whose exam is recently coming with motion in a plane? Motion in a plane is also included. Let me know if motion in a plane is also included. Sarah, in your school, I remember 2 lessons are coming, right?
Yes, ma'am.
And when is your exam, Sarah?
This Monday. Yes, ma'am.
Monday.
Yeah.
Okay. Sarah, you were also asking me something related regarding the basic maths, no? Just text me on WhatsApp today. I'll share one PDF with you, so you can at least brush up your basic mathematics with that. Please remind me once, Sarah. Fine?
Okay, ma'am.
Ma'am, there is a question.
Class, is the screen still sharing with you or not?
No, no, it's
No,
not.
ma'am.
Just wait for 5 minutes. Class, is it sharing now?
Yes.
No.
Fine. Okay, class. Now, see, next topic, that is motion under gravity. So this is nothing new. No other new formula you have. It's just that you have to abide by the sign conventions. See, what is acceleration? Acceleration, we have studied that this is rate of change of velocity. When velocity changes with respect to time, we have acceleration in nature. When this acceleration, see, whenever you have forces in nature, forces we have not discussed, that we'll start in laws of motion. Mainly you have the forces there. You must have already heard of gravity, gravitational force. Gravity, all of you are familiar with, and in 9th standard also you have this in your syllabus, gravity. So when we are talking about the gravitational pull of earth, when a body falls with when the gravity is assisting and providing the necessary acceleration, that is what we call as acceleration due to gravity. That acceleration is coming under the presence of gravity only. Like when I am walking on road, if I am walking on a road, it's not necessary that because of gravity I am able to walk, because gravitational force is being balanced by the other force that we have not studied till now, but we'll study this in laws of motion, so that will become clear through the help of free body diagrams. But you can understand this fact. But if suppose a ball is falling, I have dropped a ball, suppose I have dropped this pen, fine. So what has happened? No other force was assisting. When this pen was dropped, see here, this pen was dropped, no other force was assisting. It was presence, it was due to presence of gravity only. You have a formula, you have a separate lesson. When we end the first book, there is one lesson, gravitation. So you have this formula, capital G into capital M divided by R square. All those who have studied dimension analysis, Sarah, you also had studied recently, all of you have studied. There we studied about gravitational constant, universal gravitational constant. We had seen a formula. So the same gravitational constant is there, mass of Earth is there, radius of Earth is there. This is what we call as acceleration due to gravity. So this value, when you put all the constant values, when you put the value of G, mass of Earth, radius and everything, this comes to be exactly 9.8 meter per second square. Sometimes you round it off, we write it as G mostly to represent acceleration due to gravity. We round it off and use it as 10 meter per second square. So in some questions it is mentioned, take G as 10 meter per second square. If nothing is mentioned, use 9.8. But in most of the questions where the calculation part can be easier using G as 10, it would be mentioned to you in the exam. In the questions we'll also study. So no need to go into details of acceleration due to gravity, because you will be studying this. You have a whole derivation for this formula, and no need to remember even this formula. What you have to remember is this 9.8 meter per second square, and this rounded off you can remember 10 meter per second square, which will be mentioned in individual questions. So this is independent of mass of body, shape or size. Now this is very important. Always remember, acceleration due to gravity acts downwards. Your initial velocity can act upwards, downwards. Fine. Your final velocity can act upwards, downwards. Displacement can occur upward, downwards. But one thing that will remain fixed is acceleration due to gravity will always act downwards. So whenever you are choosing the sign convention, whatever is given to you, you have to keep in mind acceleration due to gravities. This direction will always be downwards. Rest of the changes will be given in the question. For example, if I say, suppose again, I have dropped this pen is falling downwards. So displacement is occurring downwards. Let's say initial velocity was acting upwards. I had thrown this like this. So initially this was going up and then it came down. So let's say initial velocity was acting upwards. Displacement acted downwards. Things can change according to question, but which quantity will always remain same? That is acceleration due to gravity's direction will always be downwards. Fine. Now see, regarding the sign conventions is completely up to you. You have to choose one sign convention for one question. Suppose I have chosen upwards as positive and downwards as negative. So now nothing new will occur in your formulas. Nothing new will occur. Those three equations, those four equations of uniformly accelerated motions which you have studied in the previous section, that will be the same exact. Difference is that there we weren't changing our signs, right? Initial velocity is given as this, the body starts from rest, the final velocity is this. We were just putting the magnitudes directly. Motion under gravity, you have to keep in mind the sign conventions. Why? Because here, no. And one thing that will always act downwards will be. So suppose you choose anything. This is not fixed. What is fixed? Acceleration due to gravity, direction downwards is fixed. Whether you can choose upwards as positive, you can choose downwards as negative, upwards as negative, downwards as positive. That is completely up to you. So whatever, suppose I have chosen upwards as positive. This is just an example. Upwards as positive, and I've chosen downwards as negative. Fine, this is what I have chosen. So all the quantities in the question which will act upwards will be positive for me, and whatever quantities are acting downwards will be negative for me. So when I have to consider G, that is acceleration due to gravity, I'll put a negative sign in the formula itself. This you have to keep in mind when you're solving. A ball, for example, a ball is thrown upwards. let's say this, let me give you this example. A ball is thrown upwards with initial velocity 3 meter per second square. Let's say I have chosen upwards as positive and downwards as negative. This is just a random example I'm telling you. So see class, initial velocity is acting upwards. Gravitational acceleration due to gravity, g, which is 9.8 meter per second square, this will always act downwards. So in my formula, no, when I'll put the formula like v is equal to u plus at, s is equal to ut plus half at square, whatever, my u will be 3 meter per second, not square. And when I'll write the acceleration, which will be g, will be minus 9.8 in the equation. This is what you have to keep in mind. That is enough. That we'll see now through the questions only. Quickly note down this introductory part. We'll see the questions.
Done, ma'am.
One more thing, class. See, when we are talking about motion under gravity, we are just talking about, let's say, time of ascent means when the body starts its motion and goes to the maximum height that is possible. Find the maximum height that is possible. So this is known as time of ascent. And when the body is dropping, coming back, this entire, when the body is coming back, this is time of descent. So time of ascent is equal to time of descent. Means when the body is moving from here, going its maximum value, this is time of ascent. And when the body is coming back to ground, this is time of descent. So this is 0. This is one point which you have to remember. Sometimes it is very helpful in your calculations. And this maximum velocity, this is the most helpful point for you. All your questions will be solved by this. Velocity at the highest point is always 0. Then only the body comes back to ground. See, when I am throwing this is coming back to the ground. Why? Because when this is going up, velocity is decreasing, and velocity is becoming 0. The body stops here. Velocity becomes 0. No more velocity is present to further push it up. So that's why the body comes back to ground. Whenever, suppose I'm throwing this, if I throw this is coming back to ground. You can notice a point because this is happening in so much less seconds that we are not able to observe. But if it occurs in very slow motion, you will be able to see this is coming, it is stopping here, and it is coming down. So your velocity at highest point is 0. Then only the body is able to come back because no velocity is present. So initial velocity here is 0. Now it is coming back to ground. This you can note it down together. I want to practice this question with you. This says that a ball is thrown vertically upwards, fine, with a speed of 19.6 meter per second from the top of tower. Means this is a tower, let's say. From here, the ball is thrown with the speed 19.6 meter per second. Fine, this is what has happened. And then it goes up and it comes down, returns to earth in 6 seconds. Let's say this is the highest point. You have to find the height of tower. This is the initial velocity given. Total time is time that has been elapsed is 6 seconds. We have to find the height of tower. So height of tower basically means when you're throwing it up and this is coming back, height of tower will be this only, right? Height of tower will be this only. Now let me assume one sign convention. Sign convention can be anything. Let me assume upwards is positive. This is what I have assumed. See, whatever answer will come according to your sign conventions. And in your answer sheets, never forget to miss the sign conventions. If you forget to write, what is upwards positive according to you, what is negative according to you, your answers won't match. If I am getting -4 meter per second and suppose you are getting +4 meter per second, it can happen both of us have chosen that direction as opposite. Let's say my answer is upwards, which is I have chosen negative. So I'm getting -4. You have chosen upwards positive. You are getting +4. Both the answers are right. But if you do not mention your sign convention, how will we know whether your -4 is upwards or downwards? So always mention this first whenever you have motions under gravity. Just so upwards is positive, I have chosen. Downwards as negative. Fine. Now what all things? See, initial velocity. Ball is moving up. Initial velocity is going upwards. So what is upwards? I have chosen positive. So this will be in plus 19.6 meter per second. Acceleration due to gravity. It will always act downwards. What have we chosen? What is our acceleration? This will always be -8 meter per second square. Fine, this will be -8 meter per second square. The total distance is actually this part, then this part. The body is actually coming like this. The body is moving like this and coming back on ground. So you have to consider this distance as well. Now let's write our equation. And let's put in all the things. S is equal to ut plus half a t square, because time is also mentioned. 6 seconds. See, this is displacement. This is S is displacement. What was the displacement? Height of the tower. See, actual distance was, suppose this is the tower. This is the tower. The ball has been thrown from here. The body moves and comes back to the ground. This is the actual distance. This was also covered. But when we are considering displacement, do we consider this the total path? Whenever we are considering displacement, we always consider the initial point and the final point. So initial point and final point, that becomes the height of the tower. Understood? So that's why we are considering it as h. Now,
Ma'am,
yes, Sarah.
in this question, can we take G as 10?
What?
Can we take G as 10?
G as 10, no, we cannot. It is not given in the question. You cannot. Fine. In the questions, it will be, most of the questions you will see, practice it today. You will notice most of the questions have written in the bracket G as 10. Take G as 10, then only. And in this question, you will notice 9.6 is also given. So that seems 9.8 is better. But if it is mentioned, then definitely take. But if it is not mentioned, please do not take it as 9.8. So displacement will be, see, this is the displacement. Now see, displacement, body is coming downwards. Displacement is down. So your displacement will, instead of writing h, whenever we are solving questions regarding motion under gravity, I have told you, everything remains the same. S is equal to ut plus half at square. You've already studied. What is the difference that came? We'll not now just put it as h. This will be -h, because displacement is downwards. Initial velocity is 19.6. Time is 6 plus half. Acceleration due to gravity is downwards. So again, we have chosen downwards as negative, -9.8. Time is 6 square. Whatever will be your answer, that is the height of tower. Whenever you solve this, see, this will be 117.6 minus h minus 36 by 2. This is minus 176.4. 58.8. Height is 58.8. Please cross check once also by your calculations. This is the height of tower. So motion under gravity, you can solve all the questions. This is nothing new. Just keep in mind the sign conventions. Had u been negative, if the initial velocity was downwards, how will you identify whether initial velocity is downwards? Suppose the packet, the food, whatever was dropped in this question, it was thrown like this. Initial velocity acted downwards. But in this question, it has specifically mentioned that ball is thrown from the top of tower. If something is thrown from the top of tower, it will be thrown like this. That's why we know that initial velocity is upwards. it would have also given that from the top of tower it is thrown downwards, then initial velocity will act downwards. This is how you have to identify. Quickly note down these points, just make a note point for this.
Done, ma'am. Ma'am, are you going to do something else after this?
Yes.
Are you going to do anything else after this?
No, we are going to just practice one more question after this. One more thing. Yes. Good question. See, velocity is highest. Yes, yes. At the highest velocity, V will be 0. That is right. Acceleration won't be 0. You will have acceleration. You will have acceleration at this point. V velocity at highest point is 0, but at that moment also acceleration due to gravity keeps on acting downwards. Fine. So V is 0, acceleration due to gravity is not 0.
And what is written there, like task and T descent?
This
Yeah, ma'am.
T ascent, time of ascent is equal to time of descent. Means whatever time has been elapsed by the body to go and reach the highest point is equal to time that has been elapsed by the body to come back to the ground. Fine.
Yeah, ma'am.
And your velocity keeps on changing. At highest point, it is 0. So when the body is going up, velocity will decrease, 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 and reach 0. And when it will come downwards, it will increase, 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 and reach whatever it is, its velocity's value is there. So it's not like your velocity is remaining constant. Velocity's value will keep on changing. But you have to remember that at highest point, this would be 0.
Can you show the figure again?
Question or the answer? This part?
From the figure.
Figure. Done, all of you?
Done, ma'am.
Just one small question I want to discuss right now. Two questions are there. One will come in your class assessment today. So at least you will practice it first, and then in the next class, I'll discuss it. One question is there, but I think its calculation will take time. One question is very small. This we'll do it later. This question. It's just that in this question, no, I want to tell you one thing. It says that a food packet is released from a helicopter. Suppose a helicopter is there, a food packet is released from this. Now helicopter is moving, it is saying, which is rising steadily at 2 meters per second. Means this helicopter is rising at 2 meters per second. This is moving and a food packet was dropped from it. This was the case. Helicopter was moving and a food packet was dropped from it. What is the velocity of the packet? See, class, in this question, if this is, suppose this is the helicopter, when the packet is thrown, initial velocity of the packet is actually the velocity of the helicopter only, right? If you are also resting within the helicopter and the helicopter is moving, you will acquire the same velocity if you are at rest. So here also, when the packet was initially moved, no, since it was coming from the helicopter, that's why its velocity, initial velocity will be 2 meters per second. But again, class, one thing we have to choose. Let's say upwards is positive, downwards is negative. You can choose any sign convention. Your final answer's magnitude will depict you the actual direction. So u is 2 meters per second. So it is going upwards. So this will be plus, right? Initially, if a packet is thrown, it is thrown like this because helicopter is moving upwards. So packet will be thrown like this, right? So if the packet is thrown like this, because helicopter is moving upwards, so packet will be thrown. So initial velocity will be plus. Acceleration will be minus. See, Sarah, in this question, like it is mentioned. So now I will take this as minus 10 meters per second square. Time is also given as 2 seconds. V is asked. So see, now this is an easy question. V is equal to U plus 80. V is equal to 2 minus 10 into 2, which is minus 18 meters per second. Now pay attention to this. If my answer is coming, V is equal to minus 18 meters per second, this means final velocity's direction is what? Final velocity is acting downwards because my answer is coming negative. This is telling because I have chosen downwards as negative. Suppose, let's say someone else, let's say Martin is solving this question. He chooses upwards as negative and downwards as positive. So when he will solve this question, his velocity will come plus 18 meters per second. That will show again downwards, right? That will also show downwards. Why will it show downwards? Because according to him, his sign convention was downwards as positive. Answer should always, the direction should be same. If my answer is coming downwards, his answer should also come downwards. Now, if he has chosen downwards as positive, downwards as negative, that is not what will change your answer. If my answer is coming minus 18 meter per second, that means velocity is 18 meter per second downwards. If you want to take downwards as positive in this question, your final answer should come positive. If your final answer is still coming negative and your upwards is and you have chosen downwards as positive, uh, downwards as negative, and your answer is coming positive, then your answer is wrong, because that tells magnitude is right but direction is incorrect. Fine, so just pay attention to all this. Quickly copy it down. So 2 more questions are there. Class C, on Thursday, Friday you have your test, no?
And can you show the final answer? Ma'am, tomorrow I have exams, so if you're not going to do anything else after this, can I leave?
Okay, Sarah.
Thank you, ma'am.
Martin, Afnan, Siddhika completed.
No, I'm doing.
Okay, just text me done once you have written. Done.